Hi, we're on the second part of 4.2, the second lesson, and I believe that we will only have two for this section. So we're just still solving by substitution. And if you look at these two equations, the easiest one to solve for would be, I guess we could kind of on either equation, but I'm going to take the first equation and solve it for x. Okay, so I have this 2y equals x plus 2, and I'm just going to subtract the 2. So 2y minus 2 equals x. Okay, and then on the second equation, I'm going to put 2y minus 2 in for x. So I will have 6 times 2y minus 2 minus 12y equals 0. So that is 12y minus 12 minus 12y equals 0. And look what happens to the 12y and the negative 12y. That's 0. So now I have this. Negative 12 equals 0, which is not a true statement. So these two equations would have been parallel, right? They would have the same slope, but they would not have the same y-intercept. So this would be called no solution. And you can see that this is a false statement too, and so that means we can't have a solution for this particular set of equations. All right, here's the next one. So if I'm going to solve one of these for x or y, it gets a little bit trickier, as you can see. So I'm going to just take this one and write it out here. Okay, so I subtract the 3y. I have negative 3y plus 18. Divide everything by negative 1. So x is 3y minus 18. You have to be really careful on your signs with these. Now I'm going to substitute this for the x in the second equation, right? I solved this first equation. I have to substitute into the other equation. So it's negative 3x. So in place of x, I put 3y minus 18. That's plus 2y equals 19. So I have a negative 9y plus 54. Whoops, not 55, 54 plus 2y equals 19. And then I'm going to combine my y's and subtract 54. So I'm going to have negative 7y plus 54 equals 19. I'll just go ahead and subtract it on this step. So negative 7y is going to be equal to negative 35 when you subtract those. Divide by negative 7, and we find that y equals 5. Right, so we're going to have an ordered pair here with y as a 5, and then I'm going to substitute that 5 in for y in this equation that I had solved for x. So 3 times 5, I don't know why it does that. 3 times 5 minus 18, so that's 15 minus 18, and I find that x is negative 3, so my solution is negative 3, 5. And that's what we call our solution. Okay, next. Okay, so I would advise on this one that we take the second equation and solve it for x by adding 8y to both sides. So x equals 8y plus 4. Now on this first equation, I'm going to clear the fraction of 1/4. Okay, so if I multiply everything times 4, then I get x minus 8y equals 4. If I solve that for x by adding the 8y, then x is 8y plus 4. And now you can see that we have exactly the same equations, right? Right, those are the same. And what that means is that we're graphing the same line. And so this equation has an infinite number of solutions. And that's because the slopes are the same, the y-intercepts the same, infinite number of solutions. Okay, so we're finished with that question. Now, I threw some of these in just because the book had these and I thought you should see them. We may, when we're choosing problems for my math lab, we choose them from the book, so it's likely you might have some big messy thing like this. Okay, so we're going to work with this one over here. On the left-hand side, I'm going to combine the x's and the y's. So I have 5x minus 4x, and that's just a 1x. 2y minus 2y, so all I have is x. And then it's 4y plus 12 on that other side. Plus 12. What did I leave out? Oh gosh. It's 4y plus 12 minus 7 on the other side, right? X equals this. So x is 4y plus 5. Don't leave a number out of your equation or then it just becomes a mess, as you can see, right? Okay. On the other equation, I'll just work on it here. 6x minus 3y minus 4x equals 10. Quite a bit of work before we can even start solving. 6x minus 4x, that's going to leave me 2x minus 3y equals 10. Okay, so on the second equation, I already have it solved for x, and I'm going to take that and put it in for x in the other equation. So it's going to be 2 times that 4y plus 5, right? Minus 3y equals 10. Don't leave anything out. So we have 8y plus 10 minus 3y equals 10. So 5y plus 10 equals 10, and when I subtract the 10 so that I can isolate my variable term, I get 5y equals 0. So y is 0. And so that makes it nice to put back in the other equation. X equals 4 times 0 plus 5. So x equals 5, right? Because 4 times 0 is just 0. So my ordered pair is 5, 0. And I believe that is the end. Yes, it is. So we're going to stop right here. This is going to be the second video for section 4.2, and we're done with this section.